Hello and welcome to this Python tutorial. Today we're going to implement the KNN algorithm, K nearest neighbors. So let's start with the first step, that is to set our folder as working directory. So we go to File Explorer here, then we go to Machine Learning AZ, Part 3 classification, and then K nearest neighbors here. And that's our folder we want to set as working directory. So make sure that you have the social network add CSV file. And if that's the case, you're ready to go. You just need to click on this button here and we are all set. And now let's start to implement the KNN algorithm. So of course, we're going to use our classification template that we made in the logistic regression section. I'm just going to take everything from here to here, copy, and paste it here. All right, and now we just need to change a few things and our model will be ready in a flashlight. So the few things we need to change is actually in this section where we have to create our classifier, but it's just going to take 3 lines. You know, we need to import the library, then we need to create the object, and then we need to fit the object to our training set. So it will be very fast. Let's first pre-process the data by selecting all this and press Command or Control plus Enter to execute. Here we go, all pre-processed correctly. Now let's go to Variable Explorer to check if everything is fine. So we have our data set. As a reminder, this contains informations of users in a social network. This social network has a business client, which is a car company. The car company puts ads on the social networks, and the social networks gather the information whether the user clicked and bought the product, that is the car. So it's 0 if the user didn't buy the product, and 1 if the user bought the product. So the goal here is to make a classifier that will classify the right users and put them into the right categories by predicting if each user is buying or not the SUV. So let's press OK. And we have our training set, xtrain, ytrain, and our test set, xtest and ytest. Perfect. And now let's create our classifier. Okay, so which library will we need to import? It's the scikit-learn neighbors library. And from this library, we will import the KNeighbors classifier. So let's do this. From sklearn.neighbors, here it is, import KNeighbors classifier. All right, that imports the class. And now we're going to create an object of this class. So as usual, we're going to call it classifier, okay, equals, then we're going to copy this because we are calling the class. So copy, paste it here, and then we will choose our parameter. So let's press Command I to inspect this class, and here it is. So there are the parameters. So the first parameter is n neighbors. Okay, so which number of neighbors do we want to choose in the KNN algorithm? So we're going to pick the default number, which is 5 neighbors. That will be way enough to make a good classifier. We will see in the last section of this part how we can improve the KNN classifier, but for now let's just take the default number. So here we're going to add n neighbors equals 5. Then the second parameter is weight. Here we don't care. We don't need this parameter yet. Algorithm, we don't care either. Leaf size, we don't care. But we care about metric and p. Because as Kirill explained, the KNN algorithm is based on Euclidean distance. And we want to choose actually the Euclidean distance as a distance base for our algorithm. And to choose the Euclidean distance, as you can see, we need to first pick the Minkowski metric, and then here we need to choose p equals 2 because, as you can see, power parameter for the Minkowski metric. So that means that when we select the Minkowski metric, then when p equals 1, this is equivalent to using Manhattan distance, but that's not the distance we want. We want the Euclidean distance, and actually the parameter for this is p equals 2. So what we will just need to do is just add those two parameters, metric equals Minkowski, and p equals 2. So let's do this. Let's add here metric equals Minkowski and p equals 2. And that's it. The classifier will be ready with only those three parameters. All right. So now that it's ready, let's fit this classifier object, because this is an object of the K-neighbors classifier class. Let's fit this object to our training set. So to do this, we do, as usual, classifier dot fit. So we use the fit method here, which is a method of the class K-neighbors classifier, and then we fit it to X train and Y train. Perfect. And now it's ready. Let's select these three lines here, and here we go. Everything should be fine. And it is fine. Perfect. So these are all the default parameters that were selected by default because we didn't specify them. And now it's ready, so we can predict the test set results. Let's do this. ypred. Here is ypred. Now if we go to Variable Explorer, we will find ypred, which we can compare to ytest to see how it's doing. Okay, so this is ytest, this is ypred. So that means this is the truth and this is the predictions. So let's compare. Okay, from 0 to 6, the truth is 0, that is, the user didn't buy, and the prediction is 0 as well. That means that our model predicted that the users going from 0 to 6 didn't buy the SUV, so that's good predictions. 7th user bought the SUV because it's a 1, and the prediction is 1 as well. Great. 8th user didn't buy the SUV, 0, 0 as well. Great. 9th, 0 here. In reality, the 9th user didn't buy the SUV, but our KNN classifier made a little mistake here. He predicted that the 9th user bought the SUV. But it's okay, it's normal. We will always have a few incorrect predictions because all models are wrong, but some are useful. And this one will definitely be useful, but it will not be right 100%. So let's press OK. And now let's have a look at the confusion matrix to see in one shot the number of incorrect predictions. So let's do this. We don't have to do anything here because the template is made in such a way that we don't have to change anything except for the classifier here. So let's do this. Let's press Command or Control plus Enter to execute. And here it is. The confusion matrix CM is here. Let's have a look. Wow, not bad at all. As you can see, remember in logistic regression we had 11 incorrect predictions. Now we have 4 plus 3 equals 7 incorrect predictions. So that's a great job the KNN did here. And these are the number of correct predictions. So, okay, that's great. And now the best part. Let's look at the result. Let's see the prediction boundary to see if it's a linear classifier. Do you guess if it's a linear or a non-linear classifier? That means, if it's a linear classifier, the separator is going to be a straight line. And if it's a non-linear classifier, the separator is going to be, some kind of a curve. So let's see what it is. Let's just change the title here. We put classifier here because it's the template. But here we will choose KNN. All right. And let's do it also for the test set so that we don't forget. Classifier, okay, KNN. All right, now it's ready. It's all good. Yeah, so basically the only thing we need to change is the classifier here. We need to create a classifier and then only to change the title here because we want to specify which model we are using. So let's select everything from here to here, and then press Command and Control plus Enter to execute. And here we go. Wow, wow, okay. Yes, perfect. That's a great prediction boundary, isn't it? I mean, it looks so different from what we saw in the logistic regression. Let's enlarge this to interpret the results. All right, so here are the results. Okay, so the prediction boundary is quite special. As you can see, it's it looks like a boundary of a state in the United States or a boundary of a country. It's actually not even a straight line or a beautiful curve. It's having all those irregularities everywhere. But well, that's the KNN. That's because it's based on finding the K closest neighbors each time. So the prediction boundary for the KNN is most of the time going to look like this. And compared to the logistic regression, we can see that this classifier makes a terrific job classifying the users into their right categories. As we can see here, all the red users that are the users who didn't buy the SUV are in the red region. That means that the region where our model predicted that the users don't buy the SUV. And we see that most of the green points here are in the green region where the classifier predicts that the user buys the SUV. And remember, for logistic regression, we had a straight line, so it couldn't classify correctly all those green users here that correspond to users with a age above the average and a salary below the average, but who bought the SUV anyway because the SUV is really cool and cheap. And the logistic regression couldn't catch these guys in the right category because it was linear, and below the line was the red region here, which contained those green users. So there were incorrect predictions. But here, since the boundary is not a straight line and it's catching all the right users in the right category, well, this time the KNN classifiers could catch correctly those users and put them in the green region. So that definitely made a terrific job. And then, of course, we have some incorrect predictions, like the green users here. We can see some green users in the red regions here. So, for example, this user, this user, this user, this user. So that's okay. That's because the default parameters for KNN are selected in such a way that we're preventing overfitting in the model. They were selected in such a way that the KNN algorithm didn't fit too well to the dataset. So that's fine. Actually, that's a great model. That's a great classification. Okay, but that's the training set, and that's where our model learned how to classify the data. So let's see how it classifies the data on the new set, that is on the test set. The title is all good. So let's select this and press Command and Control plus Enter to execute. And here is the test set. So let's enlarge this. And here is the test set. And as we can see, these are also great results. Great results. Of course, the regions are the same as we observed in the training set results, because these are the regions that were generated from the learning of the algorithm on the training set. So here we're just looking at some new observations, but the regions remain the same. And so we can see that these regions are perfectly fitted to the tested observations, which are new observations, because we can see that most of the red points, which are the real observation points, are in the right region, right prediction region, which is the red region, and most of the green points are in the right region, which is the green region. So the truth is going along with the prediction. And of course, we have some incorrect predictions, but that's because we prevented overfitting. So for example, we have this one. We actually can count the number of incorrect predictions we counted in a confusion matrix. Remember, we had 7 of these. So let's count them. It's very quick. 1, 2, 3, 4, 5, 6, and 7. All right, so that's the incorrect predictions, but that's totally fine. Okay, so wow, we discovered a new classifier here. It's very different from what we saw in the logistic regression. So the thing that you must remember now, must understand, is that the logistic regression was a linear classifier, and therefore it was a straight line separating the two classes. But now the KNN is a nonlinear classifier, so that way it can separate the data even when the data is not linearly separable, which is the case here. So thank you for watching this tutorial. I hope you enjoyed discovering the KNN model, and I hope you enjoyed this graph. I can't wait to show you the next classifiers. We're going to have other surprises. So we're going to have surprises when we see especially the decision trees and random forest classifiers. We are going to have more beautiful decision boundaries, especially when we look at the kernel SVM classifier. So I can't wait to show you this, and until then,